so now we're on our notes for law of sines and cosines. But before we start the notes, we're going to go ahead and do 2 more practice problems reviewing these trig ratios. So once again, I have, 38 degrees, 12.2, and then I'm trying to find x. I am going to label that this side is my hypotenuse. And again, I have to determine what type of relationship exists between these three. Between this angle, I have an adjacent and a hypotenuse. So adjacent and hypotenuse is once again cosine. So I write down cosine of 38 degrees is equal to adjacent, which is 12.2, divided by the hypotenuse, which is x. Since I need to solve for x, I'm going to go ahead and cross multiply. And I get that 12.2 equal to x times the cosine of 38 degrees. I'm trying to solve for x, so I'm going to divide both sides by the cosine of 38 degrees. And I will put that into my calculator and see what I get. Once again, I have to make sure my calculator's in degrees, and it is. And I'm going to take 12.2 divided by the cosine of 38 degrees, and I get 15.48. 15.48. Let's do another one. All right, once again, I'm going to highlight the 3 pieces that I have, and I always label my hypotenuse. I need to determine the relationship. Between this angle, I have opposite and adjacent. The hypotenuse is not involved, so this is a tangent relationship. Tangent of y equals opposite, which is 22.1, over adjacent, which is 13.7. Well, I'm trying to find the angle, so I need to take the inverse. Anytime you are looking for an angle, you have to use inverse to find the angle. It's the only time. You don't use inverse to find a side. You use inverse to find an angle. And we get that y equals the inverse tangent. I'm just going to write it out again, of 22.1 divided by 13.7. So I'm going to put that into my calculator. Inverse tangent, second tan, 22.1 divided by 13.7. And I get 58.2 degrees. Right. So these are basic trig problems that you were supposed to have learned how to do in both geometry and algebra 2. That this is just a little bit of a review. But in all of these problems, we had an angle and some sides, and we could always find what we were looking for. But that is not always the case, which is why just using the basic trig ratios works, but not all the time. Because what do if your triangle is not a right triangle? The trig ratios only work with right triangles. It's called right triangle trig. So what do you do when you don't have a right triangle? That's what we're going to look at now. Before we look at this relation, how we're going to solve for angles and sides in triangles that don't have a right angle, that aren't right triangles, we're going to review a basic concept that you were supposed to learn in geometry, but if you didn't, that's okay. that there is a relationship between angles and their corresponding sides. So I'm going to label this triangle, triangle A, B, C. And the relationship that you were supposed to learn is that the angle and the side across from it, let's say that this angle here is the smallest angle in the triangle. This then must be the shortest side. So the angle and the side across from it, if this is capital A, we're going to call this lowercase a. If this is capital B, this is lowercase b. If this is capital C, this is lowercase c. Let's say that angle B is the largest angle. That means the side across from it must be the longest side, which makes sense because in a triangle, think about it. As you open the sides wider and wider and the angle gets bigger, in order to connect the 2 points, the side gets longer. As the angle up here by the pencil points gets smaller and smaller and smaller and smaller, the side where you're going to connect here is going to get shorter. So capital A is always across from lowercase a. Capital B is always across from lowercase b. Capital C is across from lowercase c. And the capital letters are always the angles, and the lowercase letters are always representative of the sides. Okay, so let's look at this first triangle. In this first triangle, I am given an 80-degree angle, a 34-degree angle. I'm told that this side is 15, and I guess I'm looking for lowercase x, the side across from the 34. So I need to see, is this all the information I have? One of the other things that I realize that I actually know is I know this third angle. Anytime you know 2 angles in a triangle, you automatically know the third because 3 angles have to add up to 180. A triangle has 180 degrees. So if I take the 80 and the 34, I can subtract that from 180, and that means that the remaining angle must be 66. Therefore, I know all 3 angles, and I know 1 side. This is not a right triangle, so we can't use sine, cosine, or tangent. But we can use something that's called law of sine. The law of sine says that the sine of angle A divided by side A is equal to the sine of angle B divided by side B. And it's also then equal to the sine of C divided by side C. That the sine of the angle and the side across from it, they are proportionate to one another. So when we know all 3 angles and 1 side, we can use law of sine. So I've got to look at angles and side across from it. This is the one that I need right here. And this is the one that I have right here. I have this angle and the side across from it, and I have this angle and I need that side. So I can say that the sine of 66 divided by 15, angle and side across from it, and the sine of the angle is equal to the sine of 34 degrees divided by x. Okay. Now that I've written my proportion based on law of sine, I can solve the same way I solved the problems up above by cross multiplying. So going to cross multiply, and I get 15 times the sine of 34 degrees is equal to x times the sine of 66 degrees. I'm trying to solve for x, so I'm going to divide both sides by the sine of 66. And these cancel. And now I need to put all of this into my calculator. So I need to be careful with this. And so what I'm going to do is I'm going to do the numerator first, 15 times the sine of 34. And then I'm simply going to divide that answer by the sine of 66. And it says round to the nearest tenth. I get 9.2. So x equals 9.2. So that's my final answer. Okay, let's go to our next triangle. It says in triangle EFG below, find the measure of angle F to the nearest tenth of a degree. So let's see. I know that this angle here, I know it's hard to read, that's 169, and I know two sides, and I'm looking for F. So I'm always looking for angles inside across from it, so I know this angle and the side across from it. And I need, maybe I should highlight this in a different color to make it easier for us to see. I have F, I need F, and I have the side across from it. So when I go to write my proportion, I'm going to write sine of 169 divided by 20.4. The sine of this angle and the side across from it is equal to the sine of F divided by 9.2. It's always the sine of the angle divided by the side equals the sine of the angle divided by the side. Then I'm going to cross multiply, and I get 20.4 times the sine of F equals 9.2 times the sine of 169. I'm going to divide both sides. I'm trying to find F by 20.4. And then the last thing that I need to do, because I'm trying to find F, I need to get rid of sine, so I'm going to have to take the inverse sine of this. So in order to do that, what I'm going to do is I'm going to go to my calculator here, and I'm going to do this part inside the parentheses, 9.2 times the sine of 169 divided by 20.4, and that's what I get. Now I'm going to take the inverse sine of 0.086051156. I'm going to take the inverse sine of all of that. Inverse sine 0.086051156, and F equals 4, did it say, to the nearest tenth of a degree, 4.9 degrees. Okay, there's my answer.